Okay, let's look at homework number 8, problem number 19. Right, so we're gonna get a bunch of information to sketch the graph of f of x equals e to the negative 0.5 x squared. Right, so let's do that. Right, first question, let's see, determine the domain of the function. Right, so if you have exponential function, you can plug in any real number you want. So domain is going to be negative infinity to positive infinity. Right, so let's check that. Right, got that. Right, have that. Right, so determine the intercepts of the graph of the given function. So let's find the x-intercepts and the y-intercepts. Right, so if you want to find x-intercepts, right, so we need to set set y equals 0. Right, so basically we need to set this function, which is e to the negative 0.5 x squared is equal to 0. Right, but notice that e to the any power is always positive, so this guy is actually never 0. Right, so there's no x-intercept in this case. How about y-intercept? Right, so if you want to find the y-intercept, you want to set x equals 0. Right, so plug in x equals 0, so f of 0 is equal to e to the negative 0.5 and 0 squared, which is e to the 0, which is 1. Right, so y-intercept is 1. Right, so let's type it in. Right, let's see, x-intercept is actually there's no x-intercept. Let's see here, no x-intercepts, then y-intercept is 1. Right, so let's check that. Right, so we got that. Right, continue. Right, then we want to find let's see, asymptote of the graph. So we are looking for the horizontal asymptote and the vertical asymptote. Right, so let's look at that. Right, since e to the negative 0.5 x squared exponential function never blows up, so we know that there is no vertical asymptotes. Right, right, but the horizontal asymptote, so if you look at the limit as x approaches infinity, or either a positive infinity and negative infinity, in this case it's going to be the same, e to the negative 0.5 x squared. Right, so this is going to be basically, you have e to the negative, and infinity squared is going to be infinity, so e to the negative infinity is approaching 0. Right, which means that we have a horizontal asymptote, which is y equals 0. Right, so let's type it in. Alright, so you have no, let's say there's no vertical asymptote, horizontal asymptote is y equals 0. Right, so we have that. Alright, we got it, and continue. Alright, so we are looking at the first derivative, then we are looking at the increasing decreasing behavior. Alright, so let's do that. Alright, so let's take the derivative. F prime of x is equal to, right, derivative of that would be e to the negative 0.5 x squared multiplied by derivative of the inside function. So it's going to be negative 0.5 times 2 is negative x. Right? So this is the derivative. So we set that equal to 0. So you can see that x equal to 0. Right? So this is our critical number. Right? And we can just do a number line on this. So you have a number line here. Right? So here's the x value, and the tick mark is at 0. Right? So that looks like 6. Right? So this is at 0. Right? So first derivative is actually 0 at this point. So it's 0. So we have to look at the sign. So f prime of, say, -1. Right? So if you plug in -1 here, so that's positive. This is always positive, so it's going to be positive. Right? So you have a positive sign here. Right? And if you look at f prime of, say, 1, so that's negative, that's positive, so it's going to be negative. Right? So it's going to be negative here. Right? So we know that the original function f, so f here is increasing on the negative side, and f is decreasing on the positive side. Right? So let's type that in. Alright, its function is increasing on negative infinity to 0, and decreasing on the positive side, so 0 to positive infinity. Right? Let's check that. Right? We got that. Right? Continue. Right? Determine the local maxima or local minimum. Alright, so let's look for that. Right? So you can see that at the critical point, it's increasing turn into decreasing. This indicates that you will have a local maximum at 0. Right? So let's type that in. Alright, so you have a local, there's no local minimum, let's say minima, so local max is at x equals 0. Right, check that. We got that. And continue. Right, so let's look at the second derivative, then we have to discuss concavity. Right, so let's do that. Second derivative, so this is going to be, so f double prime of x. Right, so this is going to be a product rule. Right, so derivative of this guy is again e to the negative 0.5 x squared times negative x. Right, multiply by the second guy, which is negative x, plus, right, this guy is e to the negative 0.5 x squared times derivative of negative x is -1. Right? So if you clean this up, you're going to get, let's see, so you have e to the negative 0.5 x squared, factor it out. Negative x times negative x is x squared, and a -1. Right? So we can factor this out. So e to the negative 0.5 x squared, and x squared minus 1 can be factored out as x plus 1 times quantity x minus 1. Right, set that equal to 0 to get x equals positive or -1. Right, so we can put a tick marks, right, at the -1 and also a +1. Right, then we look at the second derivative, the sign. Right, so we can try anything less than -1, so f double prime of -2. Right, so you can see that this is going to be, if you plug it in here, right? Negative 2 squared minus 1 is going to be positive, so everything is positive, so positive there. And we can try 0. If you plug in 0, that's negative, that's positive, so it's going to be negative here, right? And if you plug in 2, you can see that the 2 squared minus 1 is positive, and so it's all positive, right? So you have a positive sign here, and a negative sign there, and positive sign there, right? Which means that you have f is concave up on this interval, f is concave down, and f is concave up on this interval, right? So let's type it in. Alright, so function is concave upward on negative infinity to negative 1, and also 1 to positive infinity. Right, then concave downward on between negative 1 and positive 1. Right, so let's check that. Right, oops, I messed it up. Let's see, concave downward on, let's see, use use a comma to separate answer as needed. So I think this is okay. Right, and from concave downward. Oh, actually, sorry, I put it in the wrong way. Sorry, this is a concave downward, so it's negative 1 and 1. Alright, sorry about that. And concave upward is from negative infinity to negative 1, and 1 and positive infinity. Alright, let's check. Right, so that was it. Sorry about that. Alright, then we have that. Then the x coordinates on the inflection points are, so inflection points. Alright, inflection points, you can see that there's a concavity change at the negative 1. So there's going to be an inflection point there. And there's a concavity change there at x equals 1. So it's an inflection point there as well. Alright, so put that in. So this is going to be negative 1 and a positive 1. Alright, let's check that. Alright, got that. Alright, then we have to choose the picture. Alright, so it was increasing turned into decreasing. So not this one. This is okay, not this one. So it's between these two guys. And remember that the y-intercept is 1 and this one doesn't. So it's got to be that guy. Alright, let's check the answer. Got that. Alright, that's it. I hope that this was clear.